Okay. Hi class! I'm making this video to explain to you how to solve the problems on zero order kinetics and first order kinetics. But before we go to that, let me give you some tips on how to properly solve the problems I will be giving you. So first, you have to read all materials related to the problem. So I have given you the notes on the first order and zero order. So I believe you have read all of that. Second is you have to understand what is being asked in the problem. So you have to know what are the given and then what is being asked, if it is the half-life or the KO or anything. And then you look for the formula suited to solve the problem. And then when you are done answering, try to analyze if your answer is really what is being asked in the problem. Okay, so let's start with zero order kinetics. Okay, let's start with zero order kinetics problem number 1. The amount at 4 and 12 months after preparation of a product was 365 milligram and 341 milligram respectively. If degradation follows zero order kinetics, calculate the rate constant of degradation. For zero order kinetics, the formula of getting the rate constant of degradation is this one. So the rate constant of degradation is represented by KO, which is equal to C1 minus C2, T2 minus T1. The C here represents the concentration and the T is the time. So looking back at the problem, we are going to identify what are the given. So 365 milligram is C1, while 341 milligram is C2. The T1 for C1 is 4 months and the T2 for C2 is 12 months. So these are all our given. So since the given are complete, so we can now proceed to the solution of the KO. So with this formula, we are going to substitute. So C1 is 365 minus 341, which is C2, divided by the time 2, which is 12 months minus 4 months. So 365 milligram minus 341 milligram is equivalent to 24 milligram divided by 12 minus 4, which is 8 months. So if we divide 24 divided by 8, we get 3. So the KO is 3 milligram per month. Now there is also another way of solving this problem. Although they are both the same, if you notice, this one is negative KO. So negative KO is equivalent to C2 minus C1 divided by T2 minus C1. So comparing the two, what is the difference? Since this bears a negative, ang mauuna is the C2 to be deducted with C1, while in this formula, C1 ang nauna minus C2. So yun lang ang difference nila. Okay, so let us substitute. So C2 is 341 minus C1, which is 365, divided by 12 minus 4, T2 minus T1. So 341 minus 365, we get a negative 24 milligram divided by 8 milligrams. So if we are going to divide this one, we will get negative 3 milligram per month. But remember, this is negative KO. So in order to get the negative, we will multiply both end with negative. That is the rule in mathematics. Okay, so this will already be wala yun siya. So we have KO now. Of course, this one also will be deleted. So we have 3 milligram per month. So if you notice, whichever formula you are going to use, you will get the same answer. The only thing that you have to remember is to substitute correctly the formula. So, but if I am to choose, I would rather choose this one since it does not have a negative sign. So, in the end, you don't have to multiply it with a negative. Okay, so, but then it's up to you. So, whichever is convenient with you, so you can use that for problem number 1. Problem number 2. A product degrades by zero order kinetics. When prepared, the amount was 23 microgram. After 5 months, the amount was 21 microgram. Calculate the time when amount will be 17.5 microgram. So, let us now know the given. The 23 microgram here is the initial concentration, which is represented by CO. Because this is the amount during the preparation. 21 microgram is CT. And then, 5 months is the T1. So, the concentration at T1 is 21 micrograms. What is being asked from the problem is to calculate the time when the amount of the preparation becomes 17.5 micrograms. Okay, so with this given, we are going to use this formula. So CT is equivalent to negative KOT plus CO. We can also rewrite this formula to become CT equals CO minus KOT. Now, why did I write this one? A minus K negative KOT plus AO. Because in some books, you can see this formula. So this formula and this formula is the same. No? So A here is also represents concentration. Okay. Now, so with this formula, we are going to find KO. So, CT is equivalent to CO minus KOT. Now, we will transfer the negative KOT to the other side. Since it is negative, when we transfer it to the other side, it becomes now positive. Is equivalent, so KOT is equivalent to CO. Now, this CT we will transfer to the other side. Since it is positive, so when it is transferred to the other side, it will bear the negative sign. Kaya nga, KOT is equivalent to CO minus CT. Since we're only trying to know KO, so from this, KO now is equivalent to CO minus CT divided by T. Let us substitute. So CO is 23 micrograms minus the CT, which is 21 micrograms, divided by the time, which is 5 months. So 23 minus 21 is equivalent to 2 microgram divided by 5 months. So our KO now is equivalent to 0.4 microgram per month. So with this given, we already have our KO. Now, let us proceed to what is asked in the problem. Let us try to know the time when the product or the preparation becomes 17.5 micrograms. Using the same formula, which is CT is equivalent to CO minus KOT, we will derive the formula for T. So, time here, or T, is equivalent to CO minus CT divided by KO. So, let us substitute. CO is 23 micrograms minus the CT, which is 17.5. We will be using 17.5 micrograms because we are trying to know how long will it take for the product to degrade to become 17.5 micrograms. Divided by the KO, which is 0.4 micrograms per month. So 23 minus 17.5 is 5.5 microgram divided by 0.4 microgram per month. So since we can cancel microgram, so what will be left is the months only. So 5.5 divided by 0.4 is 13.75. Therefore, the T here is 13.75 months. So, anong ibig sabihin nito? Meaning, it will take 13.75 months for the preparation to degrade from 23 microgram and become 17.5 microgram. Problem number 3. A product is ineffective after it has decomposed 10%. At the time of preparation, the amount of active ingredient was 500 milligram. After 12 months, the amount of active ingredient was 491 milligram. What should be the expiration date if degradation follows zero-order kinetics? In this problem, we are being asked of the expiration date. But to know that, we have to compute for the time. So, looking at the problem, so let us try to know the given. 500 milligram is the initial concentration of the preparation. After 12 months, it becomes 491 milligrams. So 491 milligram is CT, and the T here is 12 months. So meaning, after 12 months, the product becomes 491 milligram from the initial concentration of 500 milligram. But what is being asked is the expiration date. So before we can proceed, we have to find first KO. So this is the formula we're going to use since the initial concentration is given. So CT is equivalent to CO minus KOT. So deriving the formula for KO, so KO now is equivalent to CO minus CT divided by T. CO is 500 milligram minus the CT, which is 491 milligram, divided by 12 months. So 500 minus 491 is 9 milligrams divided by 12 months. So the KO now is 0.75 milligrams per month. So meron na tayong KO. Now let us proceed to finding the expiration date. Going back to the problem, sinasabi na nag-decompose na yung product by 10%. So, degradation 10% means that the active ingredient is 90% na lang. So, 90% of 500 milligram is equivalent to 450 milligram. So, ito yung ating CT na, 450 milligram. Using the same formula, CT is equivalent to CO minus KOT. So, T is equivalent now to CO minus CT divided by the KO. So, substituting 500 milligram minus 450 milligram. Kasi that is the new CT. Divided by the KO, which is 0.75 milligrams per month. So, 500 minus 450 is 50 milligrams. Divided by 0.75 milligrams per month. Again, we will cancel both milligram. So, what will be left is months. So, 50 divided by 0.75 is 66.67 months. So, this is the time. So, how do we translate it to this question? Meaning, after making the product, you will only have 66.67 months to use it because after these months, it is already decomposed to 10%. So, if you're going to divide this, so 66.67 months, this will be equivalent to 5 years and 6 months. So, yung product mo may shelf life na 5 years and 6 months. Problem number 4. A drug in suspension degrades according to zero-order kinetics. If half-life of the suspension is 400 days and KO is equivalent to 0.2 mg per day, calculate time when suspension will contain 75 mg of the drug. From this problem, let us identify first the given. So, half-life is given 400 days and KO is given 0.2 mg per day. What is being asked is the time when suspension becomes 75 mg of the drug. So, this 75 mg is CT and we are being asked of the time. So, if this is what we are looking for, we are going to use the formula CT is equivalent to CO minus KT. Now, let us try to know ano yung kulang at saka given. So, time. So, derived time. So, T is equivalent to CO minus CT over K. Ang CO is not given. CT is given, which is 75 milligram, and the K, which is 0.2 milligram. So, before we can proceed with this solution, we have to find out first the initial concentration. How do we compute for the initial concentration? Let us go back kung ano yung given. So, yung given is half-life and KO. If you can recall, the formula for half-life for zero-order kinetics is 0.5 times AO divided by KO. So, from this, since given ang half-life and the KO, so we can compute for the AO or the initial concentration. So, let us derive from this formula how to compute for AO. So, we can move this up. So, T1 half times KO is equivalent to 0.5 AO. Since AO lang yung kailangan natin, we will divide it by 0.5. So, AO now becomes T1 half times KO divided by 0.5. So, let us substitute. T1 half is 400 days. KO is 0.2 milligram per day divided by the 0.5. So, we can cancel days and days. So, what will be left is a milligram. So, 400 times 0.2 is 80 milligram divided by 0.5. 80 divided by 0.5 is equivalent to 160. So, therefore, the initial concentration of the suspension at time 0 is 160 milligram. So, meron na tayong CO or AO. Let us now substitute. So, T is equivalent to CO minus CT divided by KO. So, CO is 160 minus the CT, which is 75 milligram, divided by the KO, which is 0.2 milligram per day. So, again, 160 minus 75 is 85 milligram, divided by 0.2 milligram per day. We will cancel both milligrams, so what will be left is day. So, the T is equivalent to 425 days. So, what does this mean? Meaning na, from a concentration of 160 milligram at time 0, after 425 days, your concentration now is only 75 milligram. Problem number 5. An antibiotic in its 100 ml suspension formulation undergoes degradation according to zero-order kinetics. If the half-life of the suspension is 400 days and the zero-order rate constant of degradation is 0.1 milligram per day, calculate the time when the suspension will become 75 milligram of the antibiotic. If you notice, this problem is the same with number 4. The only difference is the value of the KO. So, the value of the KO here is 0.1 milligram. So, ang given, half-life, 400 days, the KO, which is now 0.1 milligram, and then what is being asked is the time for the drug to become 75 milligram. So, 75, again, is CT. Then, we are looking for time. So, with this is still the same formula that we're going to use. CT is equivalent to CO minus KOT. And then T is equivalent to CO minus CT over K. Now, we cannot proceed because we do not know the initial concentration. So, we have to find the initial concentration. So, the formula we're going to use is the T1 half is equivalent to 0.5 AO divided by KO. So, to solve for the initial concentration, AO, so this is equal to half-life times KO divided by 0.5. So, half-life is 400 days times the KO, which is 0.1 milligram per day, divided by 0.5. 400 times 0.1 is 40 milligram, divided by 0.5. So the initial concentration is 80 milligram. So we will substitute this 80 milligram to this. So CO is 80 minus 75, which is the CT, divided by the KO, which is 0.1 milligram per day. So 80 minus 75 is 5 milligram, divided by the KO, which is 0.1 milligram per day. Again, we will cancel both milligram. So what will be left is day. So the T now is equivalent to 50 days. The only difference of this problem with the previous problem is the KO. If you can see, if there is a change in KO, there is also a change in the initial concentration as well as the time for the drug to decompose to the same amount of 75 milligram. Let us have a summary of the formula that we have used for zero-order kinetics out of the 5 problems that I have presented. Okay, so the first, KO, can be solved with this formula, which is KO is equivalent to C1 minus C2 divided by T2 minus T1. So C represents concentration and T time. So we are going to use this one when there is no initial concentration that is given in the problem. In some other books, this is written as negative KO is equivalent to C2 minus C1 divided by T2 minus T1. If you look at the two, the only difference is that this is positive, this is negative. But if you want this formula, you start with C1 minus C2. But if you're going to use the negative KO, so C2 minus C1. So that's their difference. But kahit saan dyan ang gamitin mo, you will arrive at the same answer. The second formula I presented was this one, when there is an initial concentration given in the problem. So CT is equivalent to negative KOT plus CO. Again, we can rewrite this to become CT is equivalent to CO minus KOT. From this formula, we can derive how to get KO and time. So KO is equivalent to CO minus CT divided by the time. And time is also equivalent to CO minus CT divided by KO. The third formula is using the half-life. So T half-life is equivalent to 0.5 times AO divided by KO. From this formula, we can derive how to solve for AO. So AO, initial concentration, is equivalent to T1 half times the KO divided by 0.5. We can also derive how to compute for the KO from this formula. So KO is equivalent to 0.5 times AO divided by T1 half. So you only have to memorize 3 formulas, and from these 3 formulas, you can derive whatever is being asked from the question. So always remember these 3 formulas applies only for zero-order kinetics.